Alright, in this video what we're going to be talking about, how do we know whether this is an odd degree or an even degree function. Okay? So right now what I'd like you to do is go to your graphing calculators, hit y equals, type in x. Y equals x. By the way, when I say y equals x, it's like saying y equals x to the first. Alright, now let's look at the pattern here. Hit graph and look at your function. If it doesn't look exactly like this, what you need to do is hit zoom 4, and it'll look exactly like mine. Alright, so y equals x. You'll notice, by the way, this is an odd degree function. What's happening? One arrow is going down, one arrow is going up. Okay? If I go to y equals and I go y equals x squared, notice, what's this degree? This degree is even. Okay, graph. What do you notice about this? This right here, this is y equals x squared. Okay? This line right here is y equals x to the first. I go down one more. Let's go x to the power of 3, x cubed. So now we have an x cubed. We have, goes down, goes up. This is y to the first. One arrow going down, one arrow going up. Let's try x to the fourth, see if it follows the same pattern. X to the fourth. Oh no. Well, it's not this is not a parabola, this is a quartic function, but yes, it does open like a parabola, right? So, right now, even if I changed it, let's say I changed it from a positive x to the fourth and I put a negative x to the fourth. It still follows the same pattern. You'll notice it just goes from what? It goes from opening up to what? Opening down. Yeah, y to the fifth looks very similar to what? Yeah, so we're going to clear this out and we'll put x to the power of 5. X to the power of 5. Okay, graph. And it should be the green one right there. There it is. So right now, I want you guys to look carefully at our functions. What pattern does this follow? Does this follow an even or an odd degree function? I have an arrow going down and an arrow going up. Ah, very good. It is an odd degree function. So right now, we've already done answer choice A. All right, we've already done answer choice A. Answer choice B, I want you guys to write this is an odd degree function. Okay, it's an odd degree function. C, everybody, asks you for the real zeros. The real zeros are where the polynomial function crosses the x-axis. So let's put a point every single place where it actually touches the x-axis. Right here. Right here. Right here in the middle. Right there. And right there. How many real zeros does this have? That's 5. So you put 5 real zeros. By the way, the degree of this polynomial function, everybody, if I said, what's the degree of this, without even telling you the function, the degree would equal a 5th degree polynomial function. This would be y equals something x to the 5th. But you probably have an x to the 4th and an x to the 5th. That's what causes it to go up and down. Okay? So right now, we've already done answer choice A. Answer choice B is it's an odd degree. Answer choice C is you have 5 real zeros. Okay? So I want you to go over here and look at problem number 9. And look at answer choice. I won't worry about A. Let's look at answer choice B and C. How many real zeros does this have? 2. So I'm going to go right here. It has 2 real zeros. So answer choice C for number 9 is 2 real zeros. By the way, is this an odd or an even? It is even. Very good. It's even. We'll look at number 10 here in a second. But this is even now. By the way, what if I asked you to predict the degree of this? Anybody want to give me an example of what you think the degree would be? That's a good guess. Because you're basing it off of what? You're basing it off of the real zeros? But what if, Andrew, what if I said the x-axis was not here? What if the x-axis was right here? See what I'm saying? Right now, the actual degree of this polynomial function is not 2. The degree would equal 4. So when I ask you to find what would be the degree of the polynomial function, draw in a line where it would give you the maximum real zeros. Now this is not, the zeros aren't here, are they? The zeros are not right there. The actual real zeros are here. But if I were to shift this function, what? Shift this function up, right? If I were to shift it up, then you would have not 2 real zeros, you'd have 4. That's why the degree of this polynomial function is 4. So right here, let's look at number 10. Even though it only touches what? It only touches once, right? What's the degree of this? 2. The degree would be 2. And if the degree is 2, is that an odd or an even degree function? Even degree function. Okay, so that's what I need you guys to know the difference. You got to know the difference. So right now, I'm going to give you guys one right here. We're just going to make up one, and you guys tell me. Right now, we're just going to make one up and see if you guys can. So it won't take you long. Here we go. We're going to make up a function. Here we go. I know, it's odd. Ugly. By the way, is that odd or even? Even. That is an even function. Now, let's see here. How many could you have if I were to, let's see here. Go right, oh, look at that. Right there, what would be the degree?
I think it's like 6. I feel like 6.
Think it's 6?
Well, I mean, it depends on if you want like.
All right, here we go. Right here, we have one right here, right?
Yeah.
We actually have one here, one there, one there, one there, one there. So 1, 2, 3, 4, 5, 6. The degree of this one would be a 6. Okay? So, by the way, how many real zeros would this have? We have one right here, and one right there. And that one didn't touch, did it? So you'd have how many real zeros? 2. What's the degree of this polynomial function? 6. That's how you'd be able to interpret. If I ask you what's the degree or how many real zeros, that's how you know the difference. The real zeros are where what? Where the graph actually crosses the x-axis. Very good.